We'd like to represent 1 over 1 minus x as a power series that is centered at 0. And one thing that's going to be important is to recall that the sum of an infinite geometric series is always equal to 1 a over 1 minus r, where a is the first term and r is the common ratio, and that these series converge as long as the absolute value of r is less than 1. So hopefully we can see that 1 over 1 minus x fits this form, where a the first term would be 1, r, the common ratio, would be x, which means that this is equivalent to 1 plus x squared plus so on and so forth. Continuing on to x to the n, and keep going. And because that's the case, that means that this is a series that we can represent in this way. We could say this is the series as k goes from 0 to infinity of x to the k power. And notice it's 1 times x to the k, so it's really just using the form of an infinite series, right? It's the first term times the common ratio, however many number of times. And we know this series will converge as long as the absolute value of x is less than 1. And so if you can recognize the form, if it fits an infinite geometric series, you can get there quickly. 1 over 1 plus x, the first term is 1, the common ratio is negative x, which means that this would fit the form of 1 minus x plus x squared minus x cubed, so on and so forth. This means that it's an alternating series, and the first term of the series is positive. So we'll keep that in mind when we set our limits of the series from 0 to infinity. I want the first term to be positive, so I'll have negative 1 to the k power. Anything to the 0 power would be 1. When k is 1, I'll have negative 1. When k is 2, negative 1 squared is positive 1, right? So I'm getting the right type of change from positive to negative in my series. And this would be times x to the k power. So one key, if you're trying to represent a function as a power series, is can you think of it as being a geometric series? And if you can, then you can make it fit the rule. Now, sometimes you might have to be creative. Here's one, probably maybe still straightforward, but we'll take a look anyway. So we've got 1 over 1 plus 3x. Hopefully we can see that the first term in this is 1. The common ratio is negative 3x, which means this series would be 1 minus 3x plus 3x squared, right? We can multiply that out, but sometimes multiplying it out or expanding it can be hard to see. This will be an alternating series where the first term is positive, and so that informs our choice of k starting at 0 to infinity. And I'll have negative 1 to the k, again to ensure that my first term is positive, my second term is negative, third term is positive, so on and so forth. And the rest of this is the common ratio to the k power. Now, now this will converge. Right? All geometric series converge when the absolute value of the common ratio is less than 1. In this case, that would be when the absolute value of 3x is less than 1, which would occur when x is between 1/3 and negative 1/3. So this is our interval of convergence for our series. And just one note on how you know these are centered at 0. The way we have this written, I'm going to write this series in a slightly different way, make it more explicit. The sum of the series from k equals 0 to infinity, negative 1 to the k, times 3 to the k, times x to the k. This right here is showing us that we're centered at 0. This is equivalent to x minus 0 to the k power. If I needed my series to be centered, say, at 1, then my expression would be x minus 1 to the k power, to get a horizontal shift of 1 to the right. If I needed to be centered at negative 2, I would have x plus 2 to the k, to get a horizontal shift of 2 to the left. Would be a way to think about it. Let's consider one more of this nature. So we'd like to represent, in this case, 1 over 5 minus x.